Hello everyone, June the 7th. Alright, let's do this continuous subarray sum. Given integer array nums and integer k return true if nums has a good subarray or false otherwise. A good subarray is a subarray where its length is at least 2 and the sum of the elements of the subarray is a multiple of k. Note that a subarray is a continuous and integer k, x is a multiple of k if there exists n. So, okay, 0 is always a multiple of k. And, okay. So what we want is to see if has a good subarray. So we just need to find one, right? As long as one exists, then we're good. So we need to find one subarray whose sum is multiple of k. Dear me. Okay, so 10 to the 5th. Jeez. Multiple of k. Huh, how do you do this? I don't know. If you don't know the length, okay, maybe we can start by taking the I don't know, remainder. Would that work? You take the remainder and then well, the remainder is yeah, we can say the remainder is multiple of k. So we can get the number smaller. Okay, so if you do remainder, we just get a number smaller than k. But how does that help? I don't know. How does that help? Well, it helps. I mean, if we do remainder, yeah, how does that help? You still have to add them up. Alright, how about prefix sum? Prefix sum and then we do prefix sum and then we do mod. Okay, so 23, 25, 29, 35, and then 40, 42. All right, and then we mod 6. What's this mod 6? Oh my god, hand calculate. Mod 6, mod 6, mod 6, mod 6, that's a 0, right? And then we just need to find if there are two values that's the same, right? Which means these two, right? Or actually this by itself. Well, we cannot do by itself, so it has to be at least, so these three, right? These three. Okay. So yeah, all right. I think we have a solution for this. That's from yesterday. Yeah, I'm not thinking about changing my keyboard layout. I think that's way too much. I haven't even conquered the QWERTY keyboard yet. Alright, so basically we're gonna do for int I is equal to 1, I smaller than num star length plus. Actually, I don't think we need this. We don't need this. I think we just say nums. Yeah, I'm changing. I'm doing in place. So we do that, we get a prefix, and then we do it again. I go to 0, I smaller than nums dot length, I plus plus. But it's what we need to know is at which position it shows up, right? That's what we want. At which position it shows up. I just need to know the first position that it shows up, right? Yes. So we need an int. Remainders, right? Rems, new int k, right? Because we're gonna have k numbers. And for here, what we need to do is for each one, we just say int r shall equal to nums I mod k, right? And we say, oh, position. Actually, I need to set everything to -1. Arrays dot fill rems -1. Okay, and then we say if rems r is smaller than 0, then rems are equal to, because that's where it shows up, I. Okay. Else if the current position minus rems r is larger or equal to 2, 0, 1, 2, right? Then we return true. Otherwise, we don't do it until the end and return false. All right, let's take a look at this. All right, this one, right? I think I need the last. Yeah, I do think we need one more. Because when you do the minus, you never consider the whole thing. So actually, I need one more. I do believe that we need this, and we can actually return nums nums dot length -1 is equal to 0. Yeah, because the last one, if it's 0 like this, is because we can say this entire thing, right? Or you do some minus, but when you do minus, you never can minus everything. So yeah, so this is what I will do. We're going to change the last line into this, and we run the same thing, which we can test by doing, this is actually good to 1, 2, 3, 4, 5, 6, right? And then we do 6. I think the previous one, it will not be true, but right now it will be true. Yeah, it's like if we say we comment out this and we return false here, and this will show false in the last one because it didn't take into consideration. Okay, that is not what I expected. 1, 2, 3, 4, 5, 6, 7. That's because it's 7. We should do 6. 6 ones, and this will give me a wrong answer exactly, right? It will be a wrong answer. However, if we do this, this will give me a right answer. We'll test when we need to test it, but right now let's just write this. So 523. Create, what is that called? Prefix sum, right? And then take remainder, right, of each value, mod k. A subarray sum that is divisible by k will shows up if, right, if there are two remainder values of the prefix sum that are identical and differ in position by more than 2. More than 1, actually. More than or equal to 2. Okay, how about this? Okay, so now it's going to be on the whole run. Okay, so we just check one more time and it will be correct. And it's not. That is weird. How is the last one not? I think it's because I didn't set it right. Right, this is R. Yes, it's... Ooh, wait, hold on. R, so that should be... That's 1. 1, 2, 3, 4, 5, 6, right? And then this we set, and I shall have. Huh? That is weird. That should give me 0, right? And then ram 0 is small, so ram 0 is equal to. Oh, yeah. So this one just says ram 0 is equal to the last one, right? The last one. Then we just check. Ah, no, it's not. Check this. My bad. The check is to see. The check is to see if rams 0. Yes, so we shall check rams 0, right? Because that's remaining, we say 0. Ram 0 is as long as it's larger than 0, that should be fine. Because if 0 happens in the first position, then we only have 1. But if 0 happens at the second position, right? If it happens at second position, then we're already good, right? Then we're already good. So this shall be right. Okay, let's try this. Ooh. Nope. That is not right. Expected true. Because 0 is a special case. Okay, 0 is a special case. 0 and then 0. Right? And 0, wait, can we do 0 mod? Actually, I don't know. 0 mod. Okay. Interesting question. I don't know. I forgot actually. Let's go Python. 0 mod, I don't know, mod 1. Yeah, it should give me 0, right? So this one, the sum is 0, the mod is also 0, but the first one shows up as at the beginning. Damn. Okay, so that's not right. Because we only record the earliest occurrence, right? We only record the earliest occurrence. Yeah, it's earliest occurrence. If anything happens, okay, so that's not right. So what we need to, yes, so basically we need to check this, right? If this is larger than 0, then anywhere in, if it is a 0, then we'll handle it. See, that is why I suggest you just add another piece to the front. It will make this thing so much easier, right? It will make this thing so much easier. But I don't want to. You know what? I don't think it's a want to or not want to. I think you really should do it. I really think so. I think you should do it. I think you should create a new one. Call it no, just prefix sum, right? Pre-sum. In fact, yes, this is what we should do, because that's the positions, right? So if we do a prefix sum, right, and all we want is to record its position, not the positions, the the remainders, right? That's what we want. We wanted the remainders. So prefix sum and the remainder. And we need to record the remainder, the position of the remainders, right? Position of the remainders. And the remainders have all those. Okay, so let's do it this way. I don't do this. I get the remainder, because that's all the remainders, right? So this one will, let's say, record the positions, the first position of all remainders, right? And we'll do this as -1, but we can probably just do the minimum. We cannot do minimum. We cannot do minimum unless we use a really big value. We can use a really big value. Yeah, we can use a really big value, and then we just do minimum. The first time we hit it, and then no, I think this is fine. And the 0 position, right? The position, the 0 will always have a 0 position because it's the very first. And then whenever you hit it, like when you hit here, if it's a 0, then you have something. Okay, so we say remains 0 will always equal to 0. Okay, and then we'll go through everything, and then we say pre-sum is 0, right? So we say pre-sum is this, right? And then we go from the first one, and then we say pre-sum plus equal to nums I. Okay, so and then R is equal to pre-sum mod this, right? And then we say if this is smaller than 0, then this shall equal to I plus 1, because that's the position we're getting it. Else, if we say R plus 1 minus this is larger or equal to 2, then we return true. Okay, and at the end, because of this thing, we can just return false at the end. So now if we think about it, the position changes. Okay, the position is actually 1 based, right? It's 1 based. So we probably should say, so the position of remainder is 1 based. Okay, so if we have 0, 0, right? We have 0, 0. Then the remainder is k is 1. So we have 1. Okay, we only have 0. And then and everything coming out is going to be 0 because I want to do 1. Pre-sum plus equal to this. Yeah, so that's 0. R is 0. Rem 0, no. So I is 0. I is 1. 1 minus this. Right, 1 minus 0 is 1. So we'll return false. Then why is this one still return false? No. Because this is num's length is 2, so we go 0 and 1. 0 is the first one's bad, but second I is equal to 1. Then okay, yeah. Alright, let's give this a shot. So this is a little bit smarter, I think. And let's put this one in. Okay, let's try this. I think we using this little trick. Memory exceeded. Huh. I didn't expect this. What the hell is this? Memory exceeded. Holy guacamole. It doesn't allow me to make... Wait, what's the value of k? K is 2 to the 31 minus 1. I cannot make an array that big. I guess you cannot make an array that big. But all I want to know is, holy moly, that is an interesting requirement. Okay, so this is, it didn't work very well. Then we don't use this. All I need to know is, okay, we're gonna use a map. I think a map will make it work. So map integer. All I want is just, new hash map. Right. That's all I want. All I want is to give myself an idea of the first occurrence of this. So we don't do this, right? And then we don't do this. And we do this 0, so dot put 0 is 0, okay? This, and what we say is rem.get all default r, right? And we default to -1 is smaller than 0. Then we say rems.put r I plus 1. Okay, and this is else we say dot get r. Must be a variable dot put. Okay, so we are using a map. Let's see if we use a map. Yep. I think a map shall solve the problem. There we go. So definitely better than before. First time 2022, that was a lot of error. We start from 6:42 in the PM, and we didn't finish until 7:31. That's about an hour. And later on, from 9:48 all the way to 10:20. That's about half an hour. So today is 22 minutes. So yeah, a little bit better than before, but still pretty bad, I think. That I didn't realize to use the map. I guess it's all right. Yeah, but we do have to index of the first occurrence. Exactly. That's exactly what we did, right? That's exactly what we did. Oh, you set 0 to -1, so we don't have to do the other trick. Okay, makes sense. Makes sense. That's actually exactly the same, right? Exactly the same method. Prefix sum and hashing. Hashing. Yeah, exactly. Oh man. Okay, so that's that. Not too bad, but still room for improvement. Yeah, because we got the idea really fast. Okay, we got the idea of prefix sum and do the mod. We got that part really fast. What slows us down is to figure out the other thing. Yeah, I could have just do -1 and I don't have to do this part, but it's all right. Oh, we can also check if it exists. Yeah, we can check if it exists. Okay, let's submit one more time. So we do -1, right? Pre-sum, blah blah blah, and then we just say if it exists, right? Dot contains. I think it's contains key r, right? If it's not contains, then we'll put. Then we don't need this. Otherwise, we do this. Yeah, I wonder if this one will be a little bit faster. Update. Use -1 just for the remainder 0, and use contain key to check if a remainder has been encountered before. Okay, so is this going to be slightly faster? I doubt it. Nope, it does not. So that's fine. that's not too big a deal. Okay, so let's take a look at this one. Just a few minutes. Food for thought before falling asleep. Count k subsequences of a string with maximum beauty. Maximum beauty. You are given a string s and an integer k. A k subsequence is a subsequence of s having length k, and all its characters are unique. Let fc denote the number of times the character c occurs in s. Wait, hold a second. Oh, it's the subsequence itself is unique, but s does not have to be unique. The beauty of a k subsequence is the sum of fc for every character c in a k subsequence. For example, if s is equal to this, k equal to 2, fa, fb, and fd has these values. Some k subsequences is, AB, AD, and BD. No, not some. That's all the k subsequences, because you have 3 letters, and this is the only way to organize them, right? And they have the beauty of blah, blah, blah. Return an integer denoting the number of k subsequences whose beauty is the maximum among all k subsequences. Since it could be large, return modulo. Wait, hold a second. Return a number. The number of k subsequences. The number of k subsequences whose beauty is the maximum. So there will be a maximum beauty for the k subsequence, and we want to know how many are there. fc is the number, it's not a k subsequence. Yes, I know. 2 cases are considered different if one is formed by an index that is not present in the other. So 2 cases may form the same string. Okay, that's fine. So like in the first case, right? BCCA. So all we have is FB is 1, FC is 2, and FA is 1. But essentially we have BCCA, right? So subsequence has to be unique. So we take B, we can do BC, we can do another BC, we do a BA. C, we cannot do this, but we can do a CA, and that's it. We have 4, and this is 3, 3, 2, and 3. So we have 3, so we have my bad, because this CA and still have 2 CA. So we have these 4. Okay, let's do another one. A, B, B, C, D. Okay, A, B, B, C. So we have FA is 1, FB is 2, FC is 1, FD is 1. And then K is equal to 4. So we have A, B, C, D. A, B, C, D. That's it, only 2. So that's all the same. Interesting question. Well, because we're removing, right, it doesn't really matter. So we can, technically speaking, we can just, because it's subsequence, we can sort, right? We can sort this so that there will be like bunch of A's, bunch of B's, bunch of C's, bunch of D's, right? Like that. It'll be easier to reason. And the score we already know. Then what we need to do, because subsequence doesn't really matter. Basically what it just says, we just need to consider each letter just represented by its index, and it doesn't matter which index goes where. We just put them together and it'll be fine. But now we need to k-lof them, right? We need to k-lof them. So we know how many uniques there are, right? We know how many uniques there are. So there will be now we can combination it, right? Let's say we have M uniques, okay, which can be produced by just a counter. And we have M choosing K, number of ways to choose different combinations of uniques. Okay, and for each combination, now mind you, m, the largest is 26. Okay, so we can actually do a quick computation of what's the maximum number of options. So 26 choose, usually you go to the middle, will give you the biggest number. So I'd say 26 choose 13. Let's say I make k is 13. K cannot be larger than yeah, S is only lowercase English letters. But what if K is big, right? We say length K and all its characters are unique, right? What if it doesn't exist? Exactly. What if it doesn't exist? Okay, let's say return, I don't know, let's just return 0. I have this question about the first. Let's say we want 3. We have 3. Let's say we want 4. Okay, what do we have? Output. Output is the number, so this shall output 0 because we don't have anyone that can do exactly, right? Therefore, if K is larger than M, then the answer is just 0. All right, the answer is just 0. Otherwise, the maximum 26 choose 13 is 1, 2, 3, 4, 5, 6. That's 10 million. 10 million different combinations. 10 million, I think it's a little bit too big, right? 10 million is too big. Come on, 10 million is too big. 10 million is too big. Yeah. I don't think, like, because K can be 13, and we can definitely get, because it's like 10 to the 5th, right? We can definitely get all 26 letters into it, and each one repeat a few times. Right? Exactly. If you're given this test case, right? You're given this test case, you know, A is repeating 5 times, B repeating 3 times, C repeating, and all the way to Z is repeating like 7 times. Whatever. It doesn't even have to be. It can just be like this. Okay? And then you say my K is equal to 13. All right. Then you have all different types. So now when we need to count, we need to find which one is the maximum. Ah, very interesting. We need to find the maximum. So we sort this, okay? So we sort this. Then what we have is basically these are the score, right? We have the highest score all the way to lowest score. Now, because what we're looking for is the maximum, right? It's the maximum. Yeah, we were looking for the maximum, and in this case, right, they're always including C, and everybody's the same. So if we have the top 13, okay, if the top 13 all have unique counts, right, unique frequencies, then it is not possible, right? It is not possible to include anyone else, because if you choose the top 13, you give the maximum. Okay, that makes perfect sense. Which also means complication happens if the top 13, actually it's not really top 13, because you might have duplicates. Yeah, so like if I have, let's say the top is 7, 5, 5, 4, 3, 3, 2, like this, right? If this is the count, you know, let's say A, B, C, D, E, F, G, okay? And we want, let's say, the top 5. So K equal to 5. 1, 2, 3, 4, 5. Okay, yeah, K equal to 5. Very good example, K equal to 5. So if K equal to 5, what we need to do is, I mean, isn't that just these 5? I mean, these two are the same, so we can including E, or we can including F, right? So E and F we can choose, but B and C we must keep. Because if we don't keep any one of them, let's say we don't keep C, and if you don't keep, you have to find a alternative, and the alternative has to be equal, otherwise it won't be the maximum. So all you need now is to find the top K, right? And if the last one is the same, then you can have more choices for the last one, right? Yeah, we have more choices of the last one. Actually, you oh, holy crap! It's not just the last one. It's the, if you have a bunch of all of these are at the same value, right? Then you have a bunch to choose from, right? You have a bunch to choose from. Okay. Yeah. So you find the top K, and you go from the last one going left. No, not really. You find the last one, you go right to find how many more do we have, and then you go to the left. No, we have to go left and right. So you go left and you go right, so you get a bunch of all have the same count, and you know how many is on here. So we need to do, let's say we have, P number is this, okay, and then this is Q, right? Then you have P choose Q, right? P choose Q. Any combination will work, right? And then you need to multiply it by this count, whatever this count to the power of Q. Because for each one you have basically, like 3 choices, right? So you say, I have how many different ways to pick them. And once you pick them, for each one, the first position you have like that number, and then you have to do the Q, right? So yeah, so that's that part, the total number you can do. And then you have this part, right? Now this part you have to choose all of them, but each one, so basically you just have, count 0 times count 1 times count 2 all the way times, and then you time the remaining as this times this times this. Yeah. Yeah. I think that's pretty much it, and we'll try to implement it tomorrow if we have the gana. Yeah, I think that's it. Right. Okay. So one more thing. The position wise, do we need to worry about the position? No, I don't think so. It doesn't really matter which position, because if you have 7 occurrence of A, you just say we have 7 different ways to choose, right? We choose this one, and I can choose this one, and you have 5 different ways to choose B. Yeah, you just multiply them together. The only difficult part is towards the end. You have to do a little bit of choice. Yep. Should be very easy to implement if this is the right way. Okay. I'll end here and I'll see you guys tomorrow. Adios.